All right, welcome everyone. Unfortunately, the video connection with my computer doesn't seem to be working to your screens. So I will refer to problems on my screen and then I'll write stuff on the board. And when we get to talking about today's activity, I can put it up on the document. All right, so with that being said, what questions do you have about the homework? Allison. Homework 13, problem 8. Okay, so this is the one where you're given a normal distribution and you're asked to find the area that's shaded in gray. All right, so for this one, your numbers might be different. Let's see, what I got was, let me turn this around. We've got a mean of 522, standard deviation of 86, and I'm looking for the area between 608 and 350. So your numbers might be different than these, but the process is going to be the same. So here we have a normal distribution, and we're looking for the area under the curve between two values, which is the same as saying we're looking for the probability of being between 350 and 608. So what calculator function can we use if we have a normal distribution and we want the probability of being between two numbers? Table 5, can you see the board or is that blocked by it? So what calculator function do we use when we have a normal distribution and we want the probability of being between two numbers? Mary?
Normal CDF?
Yeah, normal CDF. So the first thing we put into normal CDF is the lower bound of the region whose probability we want. So in my case, that's going to be 350. The next value is the upper bound. So for me, that's going to be 608. What should I put in for the third argument? The mean, 522. And the fourth argument? The standard deviation, sigma, so 86. Allison, does that address your question about this one?
Yeah.
Cool. Any questions about this one? All right, other questions about the homework? Here's that. Number 7. Is it just gonna let me do that? Nope. Okay, so number 7, this is the one where it gives you a bunch of data and asks you to find a 92 or a confidence interval. And I'll let Ray in. All right, so in problem 7, we're being given a bunch of data and asked to find a confidence interval for the mean winnings of all the players on Jeopardy. So to do this, we're finding a confidence interval for a mean. What calculator function should we use for that? A t-interval. So when you're using the t-interval, you have 2 choices about how to go about this. One way, the way that I think is easier in this case, is to use input equals data. So when you do this, your calculator is going to grab the data from list L1. So you can do stat, edit, and then type the data into L1. And your calculator will compute the mean and standard deviation for you. The other way to do this would be to do input stats. And in that case, you would need to get the sample mean and sample standard deviation and type them in, which you could either do by putting the data into L1 and then do one variable statistics, or you could put the data into the one variable statistics applet that we have on our textbook website. And then my version of this problem is asking for a 92% confidence interval. So that's a little bit unusual. So that means that I'm going to want my C level to be 0.92. Tirza, does that address your question about this one? All right. I think making sure that you type all the numbers correctly is also a significant part of this problem. Not the mathematical point of the problem, but important to getting it right. Other questions about the homework? Nettie. Problem 3. Oh, good. So this is the random sampling and random assignment problem. So random sampling refers to how you get the observational units that are part of your sample. So how you get the people that you're surveying, or the rats that you're weighing, or whatever it is. Random assignment refers to how you assign people to, say, a treatment in a placebo group. So values of the explanatory variable. So you certainly can have both of those, or just one of them, or neither of them in a particular study. Let's see. So for part B, do UWEC faculty tend to drive older cars than UWEC students? Let's think about what that data would look like as we were gathering it. What are the observational units going to be? Right?
I should know.
So we're trying to investigate whether UWEC faculty drive older cars than UWEC students. And the observational units are going to be, what are we going to write down as one row of data as we're gathering the data before we summarize it? So probably each row is either going to be one person or one car. Let's go ahead and say we're going to do a survey, like go out and gather data by asking people, hey, are you a faculty member or a student? How old is your car? So then our observational units would be people. So we'd have person 1, 2, 3, ... And what data do we need to gather from each person in order to answer this question of whether faculty drive older cars than students?
If they drive, or like how old is their car?
Age of the car. So like 2 years, 5 years, 8 years, like that. What other thing are we going to need to know? Brady?
Faculty or student.
Faculty or student? So this might be student, faculty, student, ... All right. So in thinking about whether random sampling is feasible, can we go out and randomly sample people? Like, could we say assign a number to every person and then use a random number generator to pick, say, 100 people? Sure, that seems plausible. We could get a list of students and faculty, put them together, then use that as a sampling frame. So random sampling, yeah, we can do that. As far as random assignment goes, which of these two variables is the explanatory variable? Maybe?
Faculty or student?
Yeah, we're thinking about whether a person is student or faculty, whether that affects, whether that influences or explains how old their car is. So we're thinking about faculty versus student as being the explanatory variable. Can we go up to a person and say, oh, I just flipped a coin, you're a student. Oh, I just flipped a coin, you're going to be a faculty member. Is that feasible? No. So we can't randomly assign values of the explanatory variable. So random sampling is feasible, but random assignment is not. Questions about this? Other questions about, this was problem 3, I think. Other questions about the homework? Keely. Problem 6, A and C.
A and B.
A and B. Okay. Ah, good. This is the blackjack problem. So we want to find for part A, we have the probability that you win one hand is 0.424. possible that this one also uses random numbers? Forget. And we want to find the probability that an average player wins twice in 5 hands. All right. So we have a given probability of a yes result of winning on any one hand. And we have a fixed number of trials or hands. We have 5 of them. So what calculator function can we use, or what distribution can we use, to compute the probability that our number of yeses or successes is 2? Right? Yeah, this is a binomial distribution because we have a yes or no outcome with a constant probability of a yes. We have a fixed number of trials that are all independent. And we're trying to find the probability of a certain number of yes results, of 2 yes results. And here, because we want the probability of winning exactly 2 times, we're trying to find the probability of a particular value. We want binomial PDF. What's our first argument of binomial PDF going to be? Yeah, 5, the number of trials, or the sample size. Then we'll have the probability of success, or a yes, on any one trial. So we'll have 0.424. And then finally, the value of x that we're trying to find the probability of. So finally, 2. For part B, we want the probability of winning 10 or more times in 24 hands. So here we can again use a binomial distribution because we still have a yes or no outcome with a known number of trials. But what calculator function do we want this time? Ready? Now we want binomial CDF because now we want the probability of a range of values. Is binomial CDF going to give us the exact answer we want? Or do we need to do something else to it? Okay. Yeah, we need to use the complement rule because binomial CDF can give us the probability of winning less than or equal to some number. So we need to do 1 minus that to find the probability of winning greater than or equal to something. So if we draw out a number line, we could win 0, ... up to 9, 10, 11, ... up to 24. We're trying to find the probability of winning 10 or more times. So that's our event E, whose probability we want. So E complement is going to be what's left over here, the probability of winning 9 or fewer times. So we want binomial CDF of 9. questions about this? All right. Any questions about the video you watched for today? All right. So for today's activity, who all are my notes and numbers? We have an activity using comparing two proportions to investigate whether a nurse was guilty of killing her patients. And Ray, this is the murderous nurse activity that's right here. So you can do this on your own and then submit it on Canvas to earn the participation points today.
Yeah.
Okay.
Oh, no, I just, yeah. Work backwards. Okay, so.
Enough to help you with the activity.
Alright. Okay, so it's, looks good. It's, I killed. Oh, so this. Right? There's like two parts to it.
I know.
Right. Not so many dolphins. So it would be killing versus not. He just died, right? Isn't it kill or not kill? Or the other two? Not? Always somewhere.
You just read this, you're good.
No, you have to. I think you subtract two kills from non-kills. Since the kills is bigger. You know what I mean?
So it's whether, but there's a factor of whether the nurse work.
Oh, so does it work or not work?
Probably.
Or is it like killed versus minus more? I don't know.
That's what it's like, and so like
Yeah, I would say.
Something dolphins and not.
But okay, so the novel premises in words is that there's no association between swimming and dolphin. So here I just make no association between
they're all but like.
Chrissy Gilbert working her shift and Wells.
And
During her shift. And like depth of patients during the shift.
then it's like.
Is that there is a positive association
That's how we should
between
know.
her working the shift and step. So that's the word.
That's like during.
There is. Oh, that's, and then.
Yeah.
No wonder. Okay.
Working the shift.
Yeah. What is this? So there's no.
I don't know.
Yeah, so the null hypothesis.
I can just change. Yeah.
And the alternative
What's your first name? Understand.
And number of.
You said Kristen working shift?
No, we're working. And as a number of tests.
Or we could also say.
And then the alternative is. Same.
There is an association between shifts over worked and more positions.
With mine, it's just. Association fee.
Wow, I felt that. Okay. So
Any questions so far, Ray?
the alternative is there's a positive.
You need to check the box that says show sampling options.
So this is working shift minus number of tests. Is that what it is? I think, yeah.
Are you sure you're in the two proportions applet or multiple proportions applet?
It's working shift minus. I think controls like the universal. Like universal.
So
Like
it's
control.
working in now.
It's like control, yeah. So
Do we have two?
yeah, so it's pi. So
Wait.
it's working.
Okay.
I'll show you what I see.
How do you know which one's first?
Because it dolphins this person.
Okay, yep, so you can clear out that data and put in the nursing data.
So the development, first one was with the development, second one was development. So was this one for working?
No, we've heard not working.
Okay.
Or maybe her work, yeah, her working.
And then the other one we are not.
And then.
No, the alternative. The alternative is her working minus the control. Well, it might not. Yeah. I don't know, there are 3 examples for that. Oh, no, I think it's
This is, they're like saying it's just.
Yes.
Okay.
I think HA is 518 is greater than 518.
Yeah, and then when you click show shuffle options, then it should show you the options for the cards.
So pointing this not.
I'll be back.
Does for the null, null equals 0, and then the alternative is greater than. I don't think it's minus. I think there are
Oh, yeah, you're right. Yeah, you're right. Doing a similar.
Control is just her minus.
You don't have to put equals anyway. You just put a symbol.
And
Or
we
you
have
do
to
it three ways.
over her no. Working is greater than.
So
This is
weird. I need to have symbols here. I can use it.
only the reason
Where?
why.
Oh, and the alternative.
Yeah. We're gonna have to do that. All right.
And that's what we're really
Relevance.
Not responsible.
All right, so we're just
Oh,
going to
this
equal
is
those figures.
It's the minus, the P,
the proportion.
P hat working minus P hat.
So we do the 10th one. So 40 over.
Yeah. Yeah, it's
So patient dying while she's working, so
40.
he has working.
So I think 40 over.
It's 0.1556 for working, and he had control.
Or.
So we'll do that one.
40 over 2 to the 7 minus 34 over.
Yeah, we're just using 40 because we're looking at we die, and it's just 40
Oh,
over
and then.
34 over 13. Oh, no, you got the division side. I got 2% for that one. 0, 2, 4, 6. Uh-oh. So when she works, more people die.
The total answer I got was 73. So.
What?
You're supposed to try working or
Oh, I'm still. But right, I'm not working, so she.
So like, oh, are we writing this? Yeah, we're just like. Ooh, portion of it. So.
I've been waiting to use that. Looks like we got a positive number. It's like alternate school. That's all we need.
That's a lot.
Hey, what do I do?
The number of.
Okay, I was just wondering if there's one symbol for this one entire sentence, but I guess there's not. It's just that line instead.
I watched the tomorrow's video. So if you don't get it, then I know.
You know what?
You know
Of what?
Of this, they are probably blocks. Yeah, yeah, send it to the. Oh, no, I meant the people, no, the are, so did they like?
Oh, you already did the workshop?
No, I did, I did the video.
Oh, I should do the workshop today.
No, she just said, just like, this actually.
Oh,
Like it matches.
okay.
Sorry, I didn't mean to confuse it. I was next word. No. And then. This is one. That's already.
How was iPad time?
So we got it. So you just enter the
This thing.
four and like.
You don't need any of the totals. Because
Yeah, that was one. I mean, you probably make sure.
40, 30, 40, 17.
So I'm into the more just like. Okay.
Yes.
But no, but like it's a proportion, right? So it can be different, you know. Okay. Yeah. So the total amount of.
1,000.
Blue cards equals the shift on.
Yeah.
1,000. And only 34 of those 1,000. Whereas the choose working, but like 260 people. Yeah. Out of 260 people. 40. So then there's just like. The ratio. Yeah. So it makes it more. So whether or not. Oh, it's. Oh, no.
What is it?
My 40 plus 34.
What is the number? 74.
So, yeah.
I like A is just when she's working. So in total, there's still 74 blue cards.
And your cards represent.
So like shuffling up the cards and dealing into two piles, you're randomizing when the deaths happen.
Wait, did we, yeah, did shuffle?
Yeah.
It's on like.
You shuffle it 1,000 times.
Oh,
Eliminated the shuffle.
I was gonna say, we got the exact number that we got. I mean, it still represents how many died, so. Right. So 11.
Still
was-
74.
Okay, well.
Right, because the number of blue and green cards isn't gonna change. Just
Okay.
how they're distributed. between the groups.
So it's how many cards we have. So I think that's.
I totally sorry.
Sorry.
Yeah, but like I'm writing, are you talking about like?
Yeah.
Because you know.
Yeah, well, green and blue.
This is saying like. Right?
Oh.
But I think if you.
They're during shift.
Patients that are during shift.
No, just at the hospital. during shift. Blue ones are-
Right, and then this is
Kristen's
she's
shift.
not.
Compute p-value.
Please tell me this is people.
Yeah, it does it for.
Okay, good. Good, yeah, so calculate how many.
Green is one thing, or the ones that are.
Yeah, green are live, blue's dead, but total, that's just all the patients. that-
So. I don't have the numbers.
Oh, we use this thing.
Oh, yeah.
1.1311, and we want greater than.
Yeah.
That's our.
Yes.
Yeah.
And p-value, just one person are very.
Yeah, it's. Tell approximately.
Oh, someone's a murderer.
So there's enough evidence. That.
We don't have to do really comprehensive questions. There's some.
Yeah. It's very strong. No, nope, I know there's an answer. We have two more.
Would be no, because this is
It doesn't count for what time our shift is too.
And there's
It's like
compounding.
at night or the day or something. If your shift takes place on the holidays.
And like during the early mornings, so not.
No. Kristen's innocent.
I think it's.
What if they did that national court? They just did a. That one. You put the number for simulation. A card simulation if you get that. That was easy. Ray, did you get that? Ray, can you hear me? Ray. He's there.
He typed something in the chat.
Ray, type something. Tell me. Can you hear me?
She might have this on mute. No, I can't tell.
Because then she talks to Rachel.
Yeah. I know.
She, yeah.
Oh, something too much. That's it. What do you say?
Yeah, I can. What do you want? Ray, did you finish it? Maybe did.
Yeah.
Your group is talking to you.
He's done yet.
He's on number 6.
Yes.
How back is that?
Like Miss Black Coffee.
Exactly. You do it yourself. What, it's over here?
But I think as long as it goes on.
Like he's just like.
No, it's fine. It's just.
He doesn't have to walk farther.
Yeah. It's still happening.
Yeah.
No.
I was walking like a mile.
Simulating.
I walked and I went to the library entrance and walked through like Schofield and all the way down. Yeah, except I stayed outside by the river, just get walk outside. I figured out last year when I was cold or smell, I just go inside and just walk down. And come out there to Schofield. Cause like we're right for something. Ray, I'm using the bathroom.
Yeah, she has. And she graded, mine's graded, how this is also. I got the notification. Should be the same as the portion of the. And if those are the same number, then it's. Maybe a pay by
Wait, did you get like? It's a great word. What do you mean?
No, the exam, for example. Is my actual exam.
I think you must.
I'm not when I saw practice quiz for
Wait, it's not one of those like quizzes you have to take.
no, this is it's the practice. Because she said she's done, she's gonna stop doing this.
Oh, I like those.
Because she's, yeah, I mean, she has the answer. Yeah. I'm not worried about it. How much time do we have?
I know it's not that long.
It's almost like this.
I know it's not that long.
I didn't remember that like.
That's because it's only like 5 questions sometimes. So you never need all the
I just
time.
never like, yeah, I'm never rushing for something. Oh, no, there's no time.
You should make it.
That's what I thought.
Wait, seriously?
Oh, no, we're thinking of bio.
Wait,
I was gonna say, I never really sort of like,
there's no time limit on this?
on the quizzes, on the exams. Yes.
So I can take like a full day to do this.
Why would you?
I'm just saying, like, I could. I want to go get lunch halfway through. Think about the question.
I mean, she'd be a little concerned if I was talking to you about why it took you that long to take it.
Better get it.
How many questions are there? Yes. Oh, it's 7 questions. But we're 11. Huh?
You know, this stuff works for CA.
Oh, yeah. Okay. What do you mean?
So like, I use this computer last, I keep using it.
Any questions, Ray?
And then what's the next?
I did. It's
No, we're gonna use that here, like, because 11, maybe it's a special case.
It expires in 2030.
Oh, no. I mean, you might.
All right, I'll do that.
It doesn't work. Well,
Last time I went, I did.
I went back to some.
I've gone at least 20 times. If not more.
Yeah.
Now that it's closer, I just like bike across and then get back.
What is like?
I don't see the points. I use like Wi-Fi, not 405.
So like,
What if
I reached like 15 minutes, but then like we started to figure out like, oh my god, I'm wasting way too much.
I use I'm not really like.
That's like semi.
Yeah, it's okay. We get that.
I love to get this good.
It's not that much of a difference.
Yeah, it is not like.
No, I already.
Well, even if we have a quiz.
Also,
When I come back, I will get extra.
I always ask. The only thing I charge more for is like, why? Except any meeting. If you get pushed double state.
It's like,
Oh,
Yeah, so like, I'll take sports.
as well.
If you want a burrito, just get a bowl and get the tortilla outside, then you'll get extra.
Yeah.
Because you can.
I don't go to school.
Like, if you're gonna get a burrito, you might as well get a burrito. Then you make it so you can't put it on.
I just think it's burritos, now I just think.
I just like that.
Did you all have any questions on our project?
Oh, that's. I just thought it was
Oh, just to
clarify. I read and it said that we can use the same, same, the responses on that.
Yes, and I think I would go the other way on that too. The same explanatory variable as long as the response variable is different.
We just can't do the same.
For the project proposal,
Yep, and we're using the same.
Oh, great, yeah.
correct.
I found one.
Did you?
Yeah, but then it's like endless, and there's not like, our number was
In this project proposal, there are instructions about two different ways that you can deal with making large data sets.
You should have came.
Which one you guys I already forgot what this was.
I don't know.
I think I'm doing like eating before you go.
It has like the different.
So, I was gonna say, let's just see what happens now.
But I encourage you to use this other time and stuff that
Oh, yeah. I don't have.
Yeah, I think.
So
I
it doesn't matter.
have a class before my.
That's fine. As long as we.
But I'd rather, let's just do it again.
What type of you writing?
So test for four. So because it's like.
Well, I guess the right way is like,
Yeah, it shows like the school setting, the school check, the teacher setting. And like the number of students, the number of students in the class, so we can choose one of them.
So.
I use
How long?
like 30 minutes. Okay, do you guys want to do it like
Oh,
together?
that's
Or just
stupid
like?
lab.
Oh, but that's like.
I fall asleep sitting there, listening to them.
I haven't looked at the.
I haven't either. I've been studying. I wasn't even these.
I think it's-
I would like have to. For this lecture exam, already on like
I'm not.
78.
I have not. I'm gonna work on it. I'm like, I'm already doing that, so.
That was me for microbiology and I did just bad.
Okay, I submitted that thinking I did so well and that makes sense.
Yeah, but you did that. I didn't even get a 17. For the good second, same time. Yeah, so
Okay.
I'm not winging anything anymore.
Oh, like they're
I
all.
give up on it. Like, I was like,
Same, I was like, after this event,
that's me every time. Did nothing to change.
Yeah.
Still something like
Yeah. You're like, okay, we did so bad, so we're gonna stay consistent, but actually wait up on the same day each week to study and go over materials. That's gonna help with.
That's right. You get someone else.
I know I'm gonna pass like statistics like this. Right.
I just
So
don't.
like I'm not. It's a really great idea. I like it.
Like, I cleaned up my own people. Right. I write anything, I just have to watch it. I didn't do that great, but I basically got that.
Did you say you have?
Well, the average is like from what I took, I don't know what it's now.
All right, we are about out of time. Thank you for your good work today. We will talk about this activity at the start of class tomorrow. Have a good afternoon.
But you guys have to remind me that we're meeting Friday.
Yeah, I should write it.
Ray asks, do I need to say anything about the type of error that could occur on number 8? Not necessarily. If you want to, that would be an added bonus, but we're just asking for, does it prove that she killed patients? And if not, why not?
I'm not ready for that. I told my partner, over the partner is to be unlucky. They are me. I mean, I hope they know me.
I don't want to. I like barely knew my stuff and I wanted to.
You're welcome. See you tomorrow.
Then you're like, oh, great.
I don't think, I think it's so frustrating.
Oh, that's nice. We're gonna get paired up with.